All right, so number 3 on 66, when Aristotle proclaimed his new theory, says 87 responded. 87, I guess, people. That, it says, it turns out, was 3/5 of expected. So naturalists can say, well, how many were expected? So what we're looking for is a number. Wow. In math, we're looking for a number. You have to think about something. We've learned this before. The fraction of a number is equal to another number. And I'm gonna come back to this for lesson 68 today, but 87 responded, and 87 turned out to be 3/5 of the expected. So 87 is a number which is 3/5 of another number. So the fraction 3/5, and then we have times a, like that. Okay, once it comes into focus. All right, let me write it this way and see if that makes a little bit more sense to you with what I'm getting ready to do. So 3/5 of some number, 3/5 of the expected responses turned out to be 87. So how do I get a? How do I get the value of a? We've been focusing on this really hard since the beginning of the year. Huh? By what? 3/5. All right. Divide by 3/5 on both sides. That would work. Can I remind you that we don't divide fractions? We actually do what? Multiply. We multiply by the reciprocal. Yeah, so why can't we just start with that? We can. We're going to multiply by the reciprocal of 3/5, which is 5/3. We've got to do it on both sides because I'm choosing to manipulate the equation in this way. Now I need you to pick up on something, guys. What's the opposite of times 3? See the 3 on the bottom. What's the opposite of divide by 5? Times 5. Do you see how the opposites appear in the reciprocal? That's why it works. Those are going to cancel, and I'll get A equals 87 times 5/3. 435 over 3. $145.
What?
Yeah, 145. Number 3. 66, number 3. Now, good. Great. 145 was the expected number of responses to Aristotle's new theory. Again, the context of the problem doesn't really matter here. All they're trying to do is set up something for you to be able to write an equation, kind of like this. So he expected 145, he got 87. The relationship here is that 87 is 3/5 of 145. Okay. 13. Oh, yes. Okay. So let's see if I can show all of this at the same time. 13. You have this fun little shape here, right? Kind of looks like a basketball court with a blob on the side. All right. So they want you to find both the perimeter and the area. So I might as well just draw it here. Now they give you these measurements, 4 here, 3 here, 12, 6, and you're expected to be able to fill in the rest. What does this really mean? Why does this have to be 3? Look at what the total amount is. What does 6 represent for the semicircle? The diameter. 6 represents the diameter of the semicircle. Therefore, the 3 represents the radius. Okay, same thing here. 4 represents the radius. Therefore, what would be the diameter? 8. And then what would be left over here? If the entire bottom side was 12, there'd be a 4 here. Why did we need to do that? For the sake of finding the perimeter. So the perimeter, again, we're just going to add up all of the exterior sides. Cora stole her highlighters back, so I got to see if I've got it. I think I might have enough. All right, so the easy parts are the straight lines, the lines that are straight. So 6, 12, 4, that's easy. But then I've got to find out, what is this curved part here? What is this curved part here? What are those called?
Semicircles.
Yes. What is the specific part that's the piece of the circle? It's called an arc. Right? It's a part of the circumference. Specifically, what part of the circumference is it? It's half. Okay? So, for the first part, C1, we're going to call that circumference of a circle with a diameter of 8. So remember, that's pi d. Why am I dividing by 2?
Because it's a half circle.
I'm only half of the circle. Good. Okay, so pi times 8 over 2. That would be 4 pi. Or, I'm going to round here. Okay? So we're going to say plus 12.56. And all of that, again, that's representing that first arc, okay? The second one is very similar, except the diameter is different. So C2, that would be pi d. Again, we're going to divide by 2 because I'm only talking about half the circumference. So pi times the diameter. What's the diameter of the orange one? 6. We're going to divide by 2, so I'll get 3 pi, or roughly 9.42. So that is my arc, the orange arc, okay? Which is different than Noah's Ark. So we're going to add the 9.42. Now let's make sure before I go ahead and cut this off that we've added everything. I have the straight sides, 6, 12, and 4, and then I have the curved portions. Okay? Again, how might this be a real life problem? Maybe you chose to make your garden this shape. I don't know. Okay? People do all kinds of weird stuff with landscaping, right? Does anybody have bordering around a section of rocks or mulch in your yard? Now, I get it. Sorry to hear that. So, interesting. That explains a lot. Most people don't do this math problem on paper. Not homeowners anyway. Let's just go buy some, and if we run out, we'll go buy a little bit more, right? But if you're a business owner, you have to track things a little bit differently because the money matters, right? Every little decision you make, right? What if your truck, it costs a whole lot of money to put gas in it because it's a huge truck? You don't want to have to go to their house more than one time. If you have to charge them for double trips, then they may think you're too expensive and they won't hire you anymore. The money matters. It's not the most important thing, no, but it is important when it comes to business. So you got to think about these types of things. Math and business decisions. How did that happen? All right, so if we just add all of these up, see, 22 plus all of that, 22, 34, 43.98. And it says that that was in millimeters. What did I just find again? Y'all okay? Is there a kindergartner out there with a slingshot? Somebody have a question? Yeah. All right, so the next thing to do is find the area. How many pieces do you want to separate this out into? What would make the most sense? 3. This blob, and this rectangle. This is not a blob, it's a half circle. So it equal what? 6 times 12 plus. Now, the sections I'm going to get at here, I need to find the area of this circle and then cut it in half. So what would the area of the whole circle be? Pi times 4 squared. To cut it in half, what do? Divide by 2. Okay? So that's going to find that half circle's area for us. What about over here? Do the same thing. Pi times 3 squared. Remember, it's pi r squared. And then we'll divide that one by 2 as well. Okay, so that's 13. If we add up all of those values, 72 plus 8 pi plus 4.5 pi. Making you hungry? Just wait till March 14th. Say the date of March 14th.
March 14th.
Okay, like with the numbers.
14.
What's the month? Way to ruin it.
3.
Oh, is that
Pi
what's
day. What? We got pi day.
If you're going to expect pi that day, expect to have some complex math problems to go along with it. No, I think it's a Thursday.
Dang.
You know what's weird?
Sorry, Tuesday.
Mr. Phillips,
Miss Moore
you should bring
will get
pizza
us pie.
since it's
She will
considered a pie.
like always call me like
I know, I thought
National
pizza
Say Hello to Your Friends.
You guys are being recorded, so
Like National Handwriting Day.
Mr. Phillips,
You should bring pizza instead of
National Bury Your Lizard Day. All right. I didn't make fun. Shh. All right. So, quiet, guys. I need to make sure I get through this because you're going to have a quiz, and I'm going to talk about percentage problems. But lesson number 14, that was asked about in first period as well. So there must be something to it that's 8, 5, M, 12, 10, Q. And then there's these other things. I can't leave these out. I've got to make sure that you see these. Now, it didn't tell you anything else. In the problem, it says find M, find Q. That means, tell me what their value is. Why did they give us these markings on the angles? What does that mean? Anything? They're the same, so they correspond, okay? I'm going to color them in because we can see it a little bit better when I do that. So they're the same, as in they're the same measurement. Right, Berkeley? And if they're the same measurement, then what's true of the triangles? What is that relationship called when all the angles correspond between two different triangles? What?
similar.
They're similar. Okay, so they're similar because of this angle stuff that they put here. If they are similar, then we're able to do something with the sides. Okay, so here's the other thing I need to make sure you see. 8 is the long arm of the little triangle. So it is going to correspond to the long arm of the big triangle. What we can do, because of that correspondence, we can write that as a ratio of 8 to 12. Notice I said ratio and then I wrote a fraction. Well, because the triangles are similar, I can do the same thing with the other sides. But I have to make sure they correspond. So the next thing I could do is maybe write a ratio of the little sides. What would the ratio of the little sides have to be? 5 over Q. You cannot put Q over 5. If you put Q over 5, it's wrong.
Why?
Because I went little to big here. I have to keep the order the same any other ratio that I write. Otherwise, it's going to be backwards.
So if you did 12 over 8 would it, and Q over 5, would it still give you the same?
It would, and I want you to pay attention to why. That's a great question. When you cross multiply here, we're going to get 12 times 5 and 8 times Q. What do we get over here? 12 times 5, 8 times Q. Now, there's one other thing. There's another way we could do this. Right? Notice I could also say, this is just my preferred way to do it, but we could say 8 compares to 5. Notice I stayed in the same triangle, the same way that what compares in this triangle. What would be the ratio that's applicable to 8 over 5?
9.
12 to Q. Now, let's see if we can answer Chloe's question here. Is that going to be the same cross products? If it's going to be the same, then yeah, it's going to work. All right. But all that to say this. This is the way that I like to do it, but you can do it either one. As long as you stay consistent with your order. So, if I solve this problem from this one, 8 over 12 equals 5 over Q. We're going to save M and 10 for later. Cross multiply, I'm going to get 8Q equals 60, so Q equals 7.5. Okay? Now, can someone else write me a proportion up here to help me solve for M? M over 10. All right, let's pay attention to the order he went. He went little to big.
8 over 12.
8 over 12. Little to big. Okay? Cross multiply, see what happens. We're going to get 12M equals 80. So M equals 6 2/3. One of the fail-safes or the checks here you should do is if you get a number for M that's bigger than 10, you messed up. You have to acknowledge that this must be the larger triangle, looking at the sides that we were given. So M has to be smaller than 10 because the scale factor of these. Anybody know what the scale factor is between these two? It's just the reduced fraction of any two numbers. So 8 to 12. What's 8 over 12 reduced? Reduce it again. 2 to 3. Okay, so scale factor there, 2 to 3 ratio. All right, what else was asked? Let's see. 18. Oh, yeah, I did 18 last period, too. Funny how that works out. That's why I wanted to do that, see what problems were most missed on the test. So 18 requires us, we have 4 3/4 over 8/9 equals 2 1/9 over x. Now you might get lost here. You might try to get started and run into a dead end because you forgot you can't do these problems with mixed numbers. So what do we have to do if we can't work with mixed numbers? Convert to improper fractions. 4 times 4 plus 3, I get 19/4 over 8/9 equals 2 times 9 plus 1, 19/9 over x. Well, now what do I do since it's a proportion? Cross multiply. So I've got 19/4 x equals 8/9 times 19/9. Okay, let's simplify that a little bit more. I'm not going to touch the left side yet, but I do need to go ahead and say, well, what's 8 times 19? I only know that quickly because I did it 30 minutes ago. Okay? Now, did you learn anything from the previous page? How do we get rid of 19/4? I can divide by 19/4 on both sides, which means I'm going to be multiplying by 4/19. Okay? 608 over 81 times 20 is 1620. I don't remember what that was. $15.39. Oops. Did I get the... Where did I get 81, folks? Man. Oh. Yeah. $15.39. All right, we're going to stop there for the sake of time. Okay. And then somebody asked me about 1 on 67. And this is going to be the most... Well, it's actually really applicable for your quiz, so I'm going to. Despite that face you were making. All right, so number 6, this is 67.6. Couscous. You guys ever had couscous?
Nope.
It's like tiny little...
Oh, yeah,
It sounds like a disease.
It does.
I got contracted couscous.
All right, $4.50 for a 3-pound bag. At Megamart, couscous costs $14 for an 8-pound bag. All right. Shh. Pay attention here. Find both unit prices and then use those to determine what is the better deal. Okay, now again, people like to spend money. They just do. You're going to eventually be concerned with what's the better deal, right? When you quit shopping at Five Below, you're going to be concerned with what's the better deal. Eliza?
Can I put my nose?
Yeah.
Do I have to say if you're good?
No, you can get the tissue and step outside.
So why does Five Below have $20 stuff?
They don't.
Yes, it does. I've seen $20 stuff, and it's called Five Below. This
After tax is always one.
Are they? Well, let's see, guys. Look. Shh. If you look at what I put on the board, a unit rate means it has what in the denominator? A 1. So here's what I got to do. $4.50 for 3 pounds equals what for 1 pound? And all you do to find a unit rate, the operation is up here. Divide. Divide, okay? You're just going to simplify the fraction. So we're going to say $1.50 per pound is the unit rate here. What is it for 14? $14 divided by 8 pounds equals $1.75 per pound. Now, do you see how that's helpful? Do you guys ever pay attention when you go shopping, or do y'all not go shopping?
I'll go shopping.
Oh my goodness, what a lie. So, price tags at Walmart.
They already have them there.
I know. That's it though. Look. Shh. Look. The unit price. Well, that's not helpful at all. Let's look at this one. Here we go. So this could be a fun little quiz. $4.56 is the price for small breed dog food. 3.5 pounds. What? 3.5 pounds. It's not a dog, it's a toy at that point. Okay? Now look at what they give you. 8.1 cents per ounce. So I'm going to ask you this, because I think this is what came up. Is that true? Is that true? You need to be able to do that. Is that true? So, what they're saying, $4.56 for 3.5 pounds. They're saying that's 8.1 cents per ounce. All right, so let's see. So, here's what we got to do, guys. Do you see that they changed units on you? We got to change units too. So, how many cents are in $4.56? It's a 5th grade question on the quiz. 456 cents. How many ounces are in 3.5 pounds? Well, let's see. 16 ounces per pound. That's 48 plus 8 more. 56?
56.
So, how do we get the unit rate?
It's cold.
How do we get the unit rate? Divide. All right, somebody with a calculator, do 456 divided by 56. Oh, man, they're right. 8.1 cents per ounce. Check it out. Shh. Now, you might think, well, that .04, is that significant? No. You got to go back here?
No.
Oh, what's up?
If you're at Walmart, what's the point of doing that? Because then you're just wasting time at that point.
Is your money worth time?
Yeah.
Is your time worth money?
Yeah. But time is more precious than money.
I agree wholeheartedly.
You get more money, but not.
This is just an exercise in can you do this, okay? All right.
A lot wrong.